Hello everyone, and welcome to part 6 of the series on creating a complete car game. In this part, we'll be working on creating the car's drift marks, and based on my experience and extensive testing, the best way to achieve this is by using Niagara, specifically the Ribbon Renderer, which gives smoother curves for the drift trails and follows them with high precision. At the end of this video, I'll also explain how to create the rear brake light effect when stopping. So this will be an easy and quick video, but with a touch of creativity as always. Let's begin. First, I have an image of the car's tires here, and we'll be using that. We'll create a material from this image, set it to translucent, and connect the texture to opacity. You can also use this same method if you want the trails to be more faded later. That's it for now. Next, we'll create a new Niagara system. Start with an empty one. Add spawn per unit. Alright, I'll tweak a few settings like this. Then, we'll delete the sprite renderer and replace it with the ribbon renderer, which is the core of today's topic. The ribbon renderer works similarly to a spline, but the difference is that we use it inside Niagara, giving us smooth and natural curves. Since this video isn't focused on explaining Niagara itself, I won't go too deep into that. We'll just change a few settings here. First, assign the material we just created. Then set facing mode to custom side vector, UV mode to tiled by segment length, and tiling length to 30. That's enough. One last tweak. Under Initialize Particle, I'll adjust the lifetime. Now, we move to the more important settings. In the Ribbon Attributes section, set ribbon width to 20, and for ribbon facing vector, things are a bit different. From here, search for System Y-axis. That's all we'll change for now. The rest will be handled inside the vehicle blueprint. One issue I've faced quite often is the delay in showing the drift effect, and I found this to be the best solution. Add a scene component to the car and attach two of them to the rear wheels. You can also add the effect to the front wheels if you want, but I think it's better to keep it only for the rear ones. Next, and most importantly, we'll build the logic for when the effect should appear. For that, we'll create a custom event. Use a for loop from 2 to 3 since we only want the rear wheels. From the vehicle component, get the wheel state. Use the loop index as the wheel number and break it. Now we'll use two conditions to determine when the skid marks appear. First, the wheel must be in contact with the ground, of course. Second, the wheel must be turning at a certain angle we define. For the second condition, we'll use get steer angle, which we can get from one of the front wheels. Just one is enough since both share the same steering angle. We'll check if it's greater than 30, then connect it with a Boolean. You can convert this value into a variable to tweak it later. And don't forget to use the absolute. Next, use Spawn System Attached, select the drift effect we created, and enable Auto Destroy. This will control whether the lifetime is active or not. For Attached Component, select from the loop index and set it to the Scene component. The last thing is to create a new array with 4 elements, leave them empty, and use setArrayElement. Let's add one more check. Make sure the current effect is not already in use. With a simple condition like this. Leave it empty. Copy the same check below. If it's not in use, then detach from component with all options set to keep world. Finally, add another set array element here, and that's it. Now just place everything inside the event tick. Let's do a quick test now. It seems there's a small problem here. The skid marks aren't showing up, or rather, they only appear at the beginning. I'll look into the problem and get back. Alright, I'm back. I found the root of the problem. Just leave this part here empty and it will fix the issue like magic. You'll also need to change a few settings here. Just add 2 additional elements and connect the scene components we created earlier to inputs 2 and 3. Yes, it's working perfectly. If you only want the skid marks to appear during drifts, you can simply increase them in angle to show skid mark value. As you can see, the marks are already quite smooth and look great. I'll do a few tests for you now. I'll add one small thing. I don't want the skid marks to appear when the car is stationary or moving slowly, so I'll add a condition using the function we created earlier. I think setting it to 45 will be ideal. Now that we're done here, next I'll show you how to create the rear brake light effect when the car stops. Currently, what we want is to light up the brake lights. The problem is that all the mirrors in the car share the same material, and we can't separate them. But here's the solution. Go to the mirror material first. For those who already have this part separated, you can skip this step. I'll recolor it white so it's more visible. Then we'll add a new color, red, which will be the brake light color. We want it to appear only in that area. To achieve this, use absolute world position. Then convert it from world to local using that node. Next, apply a mask for one channel only. After that, use subtract and abs, and finally smooth step. Then use lerp to blend between the mirror texture and the red brake light color. At first, you might not notice anything, but when you adjust the value here, you'll start to see the difference. The higher the value, the more the red area expands. Increasing them in value reduces the blend, and setting it to the maximum removes blending completely. Looking at the car, you'll notice that one half has the white mirror texture, while the other half has the red brake light color. We want the brake light to appear at the back, so adjust the value here. As you can see, keep tweaking until you find the perfect balance. That looks just right. Now we want to increase the brightness for the rear lights only, not the whole material. Follow these steps carefully. Good. Next, we want to control when this light appears or disappears. For that, we'll use a material parameter collection. Add a scalar parameter, rename it, and drag it into the material. Modify it here and use lerp to choose which texture to display. We'll also use it to control the light intensity. Now let me show you. If we set the value to 1, the rear lights turn on. If we set it to 0, they turn off again. Now let's restore the color to what it was. And yes, remove it from here and set the default value to 1. This is very important. Let's do one final test together. Perfect. Finally, we just need to define when the material parameter value changes. To do that, place it inside the brake logic using set scalar parameter value, select the one we created earlier, and set the value to 1 when pressing the brake input, and back to 0 when released. You can also link it to the drift if you want by adding it here. Let's do one last final test. Yes, it works perfectly without any issues. Alright, that's everything for this video. The next one will be very important. I'll explain how to make your car look more realistic, including speed effects, camera effects on the car, and many more details. It might be a long video, but I'll cover every effect you can add to your car. So, don't forget to turn on the notification bell after subscribing so you'll be alerted when it's released.